Hello, my name is James, and let's take a leap into the quantum world. Have you ever tried to take a picture of something moving fast like a car? The object either looks sharp but blurry in motion, or the motion looks sharp but the object itself is fuzzy. In the quantum world, this trade off isn't because your camera isn't fast enough, it's built into nature itself. Welcome to the Heisenberg uncertainty principle. What is the uncertainty principle? Heisenberg's uncertainty principle says there's a limit to how precisely we can know two things about a particle at the same time. X is its position, and p is its momentum, which is the mass times the velocity. The more precisely you know where a particle is, the fuzzier you are about how fast and what direction it's moving in, and vice versa. Mathematically, the product of the uncertainties must be greater than or equal to Planck's constant divided by 4 pi. Planck's constant is h in this formula, which is a topic that can be talked about on its own, but for the purposes of now, we'll just say it's a really small number. But why does this happen? It's because particles like electrons don't act like little balls. They act like waves. A perfect wave goes on forever and has a precise momentum, but it's spread out everywhere. You have no idea where the particle actually is. And if you squish the wave into a small bundle to figure out where the particle is, you mess up its momentum. So the uncertainty principle comes directly from the wave nature of matter. It's not a mistake or a problem with our tools, it's just how the universe works. But how do we know that this is how the universe works? We can actually see this behavior in one of chemistry's most fundamental experiments, Young's double-slit experiment. When electrons are fired through two tiny slits, they create an inference pattern, just like waves do. Even if we send them one at a time, the pattern still builds up. That's proof that electrons behave like waves and that their exact path between the slits is uncertain. It's direct evidence that the uncertainty is real and not just a theory. Heisenberg's uncertainty principle isn't an idea just for the books. It's behind real-world technology too, like lasers, semiconductors, and scan tunneling microscope, or STM. This device allows scientists to see individual atoms on surfaces, but it doesn't use light like a normal microscope. Instead, it uses a sharp metal tip that hovers incredibly close within a nanometer of the sample. When the tip is that close, electrons can tunnel through the gap from the surface to the tip, even though they classically shouldn't be able to. This tunneling only happens because of the uncertainty principle in the electron's position and energy, meaning they don't follow the classic rules. As the tip scans across the surface, the amount of tunneling current changes based on the shape of the atoms underneath. This data gets converted into a topographic image, letting us map an atomic landscape of the material. Without Heisenberg's uncertainty principle, this tunneling wouldn't happen and STM wouldn't work. Why does this matter? It matters because electrons aren't tiny little planets orbiting the nucleus. Instead of neat, clean, circular orbits, we have electron clouds, areas where an electron is likely to be found, but not known for sure. Quantum uncertainty creates the structure of atoms, molecules, and basically the structure of everything around us. Lastly, Heisenberg's uncertainty principle isn't just some weird math rule from quantum mechanics. It's a statement about how the universe truly works. It tells us that at the smallest scales, reality is not fixed. It's fuzzy. We can't know everything about a particle at once, not because of bad technology, but because nature just won't allow us to. And yet, this uncertainty is what gives structure to atoms, stability to matter, and possibly to chemistry. It's why electrons form clouds instead of crashing into the nucleus. It's why particles can tunnel, why atoms bond, and why we can even see them with specialty microscopes. The Heisenberg uncertainty principle changed the way we think about the truth in science, not as absolute facts, but as probabilities, patterns that we can understand, even though we can't control every detail of it. In a world of precision, Heisenberg showed us that there's a real beauty to uncertainty.